All right, thank you, Mike. Everybody hear me okay? Mic working? All right, so I'll
I don't know what to do with this.
just put that back in there. So it's a little weird for me to be here keynoting a Smalltalk conference and talking about something other than Smalltalk. So, but I hope you enjoy the information about Dart. Dart is a brand new language, so I'm pretty new to it myself, and it's not done yet, so it's constantly changing. Feel free to jump in with questions, and I'll try to answer them to the extent that I even know, what's going on with Dart at any point in time. And if you saw from the announcement of the talk, I really wanted to explain why Dart is now my new second favorite language, Smalltalk, of course, being my eternal favorite language forever. So no worries there. A little more about my background. As Mike said, I'm currently engineering manager for the Dart editor at Google, also Google Web Toolkit, co-founder of the third instantiation of instantiations, former VP of the second instantiation of instantiations. Started with Smalltalk back in 1991 when I was at AMS, and we were working with KSE and people like Sam back there. Hey, Sam. It's been a long time since I've seen you. Started with Java in '96. Never really liked it, but had to work with it. And Dart most recently in 2011. Co-authored a couple of books along the way, mostly Eclipse-based stuff. Eclipse plugins, and most recently the Eclipse Graphical Editor Framework GEF book. Been project manager and architect for over a dozen different products, Smalltalk, Java, Eclipse-based stuff, and also currently the project lead for the Window Builder open source project, which is Java-based at eclipse.org, which was contributed by Google to the open source community after they acquired it from instantiations. And you can reach me at Clayberg at google.com. So, agenda, talk about a little bit about the motivation for why we created Dart. There's certainly a lot of programming languages out there. Why did Google feel the need to create yet another one? Go into detail about the language itself, talk about some of the interesting like process model based on isolates, go through a number of code examples, so I'll be jumping back up and down on the podium to show you those. And then I went through I have a sort of a fairly lengthy comparison, since obviously you folks here are interested in Smalltalk, so I did a fairly lengthy comparison of the two languages, Smalltalk versus Dart. So that's the bulk of the presentation on that. And then if we still have time, I got some slides talking about the Dart editor, which is my team in Portland, which is actually the ex-instantiations team based in Portland, Oregon. They're working on the Dart editor, which is an Eclipse-based tool. We ran into some interesting challenges building that tool. So, what's the current status of the web programming world? Building small to medium-sized apps is pretty easy. Platform independence, web apps run pretty much anywhere. No installation, you just hit a URL, there you are. The platform's improving very quickly. You probably see things like Chrome coming out, new version every 6 weeks or so, and the other vendors like Firefox are doing the same. So it's moving so fast we can barely keep up with it. 50% of users out there, this is based on Google stats, are either on IE9, Firefox 7, Chrome, or Safari. So the modern web is fully in play here. So why create Dart? This is basically based on many years of experience at Google, which builds some very, very large web apps, both in things like GWT, which is Java-based, and a lot of stuff in JavaScript, where it's actually quite difficult to build big apps. So developing large apps is hard. It's hard to analyze and find the program structure. There are no static types, which makes it very hard for having any decent tools. No support for libraries, slow startup, and lots of cruft is built up over the last 15 years with JavaScript and layers on top of that. The guys that developed Dart, Lars Bach and Gilad Baraka, go back to Smalltalk days. They developed StrongTalk, along with things like the Hotspot compiler for Java, and many things along the way. They did. Lars did the V8 JavaScript compiler for Google, and they were really the guys that pushed to create a brand new language, which we ended up, after various iterations, it went through several different name changes before we finally found one that legal would approve, and we ended up with Dart. So what's the goal? Help app developers write complex, high-fidelity client apps for the modern web, and there's our little Dart logo. So what is Dart? Structured web programming, new language, new tools, new libraries. It was open sourced early October 2011, so it's brand new. It's still very much considered an alpha. I think we're looking to ship like a 1.0 version later this year. So it's the language is still in flux, and there you'll see along the way there are a number of language constructs like proposal for doing method cascades that are still in the proposal phase that haven't actually been added to the compiler yet. And you can read all about Dart and everything about it at dartlang.org, which is the open source website. So what is it? It's a simple, unsurprising language. Well, unsurprising if you're used to using Java and JavaScript. It's class-based, single inheritance with interfaces, optional static typing, and I'll go into more detail on that. Real lexical scoping and closures, which you will definitely like from a Smalltalk point of view. You've got basically the equivalent of blocks and a very nice, easy syntax for using them. Single-threaded, so rather than having a multi-threaded language and worrying about various concurrency problems and issues, Dart is purely single-threaded. Each thread runs in what's called an isolate, which is sort of like, if you're familiar with Erlang and actors, it's sort of the same kind of concept. So isolates can talk to each other by passing messages, but they don't share any state. And then familiar syntax was one of the arguments for familiar syntax to the Java and JavaScript community. There's actually a large number of Smalltalkers on the Dart team. In fact, one of the things that Lars told me once early in the process was, he really would have liked to have Dart have a Smalltalk-like syntax, but they just couldn't sell it to the greater world. But so his goal was to put as much of the goodness of Smalltalk into Dart as he possibly could, with the constraints of Dart has to compile down to JavaScript for any browser that does not have a Dart VM. So Dart actually has two modes of operation. There's a Dart VM, which will be in things like Chrome and any other browsers that will accept it. And then for other browsers, it'll compile down to JavaScript and run anywhere with the limitations of JavaScript. So there are a number of constructs like non-local returns, things like that, that are not easily emulated in JavaScript and thus are not in Dart at the moment. So here's an example of a simple Hello World app in Dart. You can import libraries. You have concept of top-level functions, so a method can exist both in a class or as a top-level function just in a file. You have classes. You have methods, which can be typed or not. Optional types, so any object, you can either specify it as a var, meaning it can be anything, or you can specify it as give it an actual type. The types are actually just more there to help the tools. At runtime, they actually have no effect. You could actually go in here and mess up the types completely, and the code would still run, since the type information is actually ignored completely at runtime. It's basically a dynamically typed language at runtime with optional types to basically help the tooling. So it's an interesting approach. Which basically means that the type system is completely unsound, if you care about things like that. But that's actually one of their goals. So optional static types, a low friction tool for developers to make the intent more clear to humans and machines. As you start out, you can start out untyped, and then as you grow the scale of the program, you can then add the typed information to it if you want to. And then that typed information then makes it a lot easier for tools like the Dart editor to provide code assist functions, refactoring, and things like that. So yeah, the types are really there to sort of document the intent of the program. And you can actually, if you want to, you can check types at runtime. You can ask, is something of, is an object of type T, or is it null, things like that. But by default, the type adaptations have no effect and no cost. Isolates, inspired by Erlang. Lightweight units of execution. Each isolate is conceptually its own process. Although if they are lightweight, they could all run in the same UI process. If they're heavyweight, they could actually run in separate processes. Nothing is shared between them. Everything is done, all communication is done by message passing. And they support the concept of concurrent execution. So one isolate can spawn another, and once they've set up, there is a send port and receive port, and they communicate back and forth with simple messages, and they basically go off on their own. If you have, and you can specify when you create an isolate whether it's a lightweight or a heavyweight. And on a heavyweight, when compiled to JavaScript, like under modern browsers like Chrome, they'll be actually instantiated as full-blown web workers. A lot of potential for use of isolates, isolation of third-party code, security, JavaScript interopt, and it provides a uniform model both for client-server and inter-client. So one of the nice things about Dart, and where it sort of improves the current state of the world, in the current state of the world, most server programming is done often in Java, and client programming is done in JavaScript. With Dart, Dart is both a client and a server language, so you can run the same language in both places. There are a couple, so on the Dart website, we have a nifty little tool called Dartboard, which is basically a little interactive console where you can actually type in Dart code and execute it and play with it right there in the browser. Anytime you create a little new snippet of code, it gives you a URL so you can actually pass those snippets around pretty easily. That's what it looks like. You can select various templates, a bunch of built-in ones available, like is the Fibonacci one. You can type whatever you want, run the program, and then it'll basically show you the results. The Dart editor, which was created by my team in Portland over the last year or so, is basically the tool that we're offering to let you edit Dart code. It's an Eclipse-based tool. We initially started out building a set of Eclipse plugins, but we quickly found that most web developers are not coming from an Eclipse point of view. So they were used to using various text editors and Emacs and TextMate and things like that. So they were expecting something that would start up in 2 or 3 seconds. And if you ever used Eclipse, you go start it, go grab a cup of coffee, and come back, and it's finally there a minute later. So having the Dart editor as a plugin to Eclipse didn't work out very well for us. So we decided to go the approach of doing an Eclipse RCP app, and we basically stripped Eclipse down to the bare bones, got rid of every possible thing we didn't need, and the result is the Dart editor starts up in 3 or 4 seconds compared to Eclipse starting up a minute later. So it's worked out quite well. And eventually, at some point in the future, we might create a new Dart editor written in Dart itself. But at the time that we started this effort, Dart was way too early in its history, so we had to pick something out there to build it with. So we had a bunch of Eclipse developers, so we went with Eclipse. Everything in Dart is open source, including the editor, so you can go download the code or download the pre-built binary that we provide. And the result is, if you're familiar with looking at Eclipse, you would normally see a menu bar just full of stuff and menus just full of menu items. With this tool, it really is very simple, very clean, nothing there that you don't need. We basically stripped it down to nothing, and now we're slowly building back up, adding functionality to it by trying to keep the interface as simple as possible. And at the end of the talk, if we have more time, I'll talk some more about what we did to develop this. So what's the Dart execution model? Well, you start with Dart source, and the interesting thing is the Dart VM is a source code based VM rather than a bytecode based VM. So it actually parses the source code directly rather than having a compiler convert it into bytecode and then running bytecode. So that's an interesting aspect of it. Tools like Dart editor or the Dart compiler can also compile Dart down to JavaScript so it can run anywhere. And it also has a concept of snapshotting. So similar to a Smalltalk image, once the Dart program is running, you can create a snapshot of it, store it, and then use that snapshot to start up the application under the Dart VM, often about 10, 15 times quicker than if you had just simply started the VM on the Dart source itself. So for example, again, it's just basically the heap serialized after the application is loaded. Performance-wise, taking a sample application with 54,000 lines of Dart code takes 640 milliseconds to start up. The same application, when using a snapshot, takes only 60 milliseconds, so 10x faster startup. Now that approach requires the VM, so it'll work in things like Chrome once the Dart VM is deployed there. On other browsers without the Dart VM, you're looking at basically having it compiled to JavaScript and having the JavaScript run. One of the sample applications is just an example of the kinds of things, a number of fairly sophisticated things have been built so far. One of them is called Swarm, which is a news reader completely written in Dart. The application itself is about 3,200 lines. It relies on a UI library that's about 13,000 lines, compiles in about 2 seconds, and results in about 500 kilobytes of JavaScript. And I'm going to jump back up here and just show you some code examples because we all like code, and actually looking at the code you get a better appreciation for what the language is like. And those lights are very hot. All right. So here is the Dart editor. When it starts up, you basically just see the folder here for the SDK libraries. Has this welcome page where we have a bunch of built-in examples like a clock and a slider, sunflower, and a few others. This example, this is basically a absolutely minimal Dart application. So basically, Dart applications start with a main function, which is expected to be at the top level of your Dart file. This little arrow syntax is basically a shorthand for defining a one-line function. So we could have defined this with our standard curly braces like that. That basically is exactly equivalent to that. So just so when you see this equal sign angle bracket, that basically defines a one-line function. And you'll also see the same syntax when defining blocks or anonymous functions. So if we run this, it just, I don't know if you can see in the console, it just said hello, as you'd expect. Then some other ones here, generics. So the language has support for generics. So if we run this, it'll show us a bunch of true falses. So you can see a type, a new list is the same thing as a list of new objects. There's also a dynamic type, so it's a list is also a list of dynamics. A list of strings is also a list of objects, but a list of objects is not a list of strings, as you'd expect. A list of strings is not a list of ints. A list of strings is a list, and a list. Yeah, you can pass a list anywhere a list of strings would be expected.
I have a question.
Yeah.
So if you said you could do a runtime querying of an object, kind of its type was. So if you've got a list and you ask it, are you a list of integers, or how does it know? Because maybe it is going to have something else later. Did you hear that? Should I?
Yeah, no. Well, if it did have something, yeah, that's a good question.
So the type system doesn't know.
Yeah.
What's in it. So there's a question of, the question of what the type system knows and the question of what's actually in it are completely separate questions. So are you asking about, are you asking the list what do you contain, or are you asking it what are you as far as the static type system knows?
Right.
Are different things.
Yeah, you could actually stuff anything in there and violate the type system if you wanted to. In fact, you could create a variable, say it's an int, and then stuff a string into it, and Dart actually wouldn't care. Like I said, the type system is actually intentionally designed not to be sound. So there's been a lot of, let's say, vociferous discussion on the mailing list about the kind of type system that Dart has. But fundamentally, you have to think of Dart as being an untyped language. And at runtime, it acts that way. So anything can be assigned to any variable. The types are there simply to document and help the tools analyze the program. So if you actually want to do something completely weird and assign a string to an int, it'll happily do that, and it'll actually run. In fact, if you said, int x equals some string, and then printed x, it'd print out that string, because that's what it is. So, has lexical scoping. So who can take a look at this and guess what's going to be printed when we run this function here? There's lexical scoping and dynamic scoping, so depending on what kind of scoping you have, you actually get a different answer to this code. So in Dart, it'll print global x, which is lexical scoped. If it was dynamic scoped, it would print out b.x, which I think is what you get in JavaScript. All right, isolates. Now, isolates, again, are the way for you to set up basically multiple processes communicating with each other. So in this example, we're going to start by spawning this simple sender isolate, which sets up a receive port. It'll print out whatever response it gets, and then it goes and starts up this echo isolate that just accepts a message and then echoes it back. So, and then it's going to send the message hello. So what this does, if we run it, see it sends a message hello, and then it gets a response back, echo hello. So you can basically set up these isolates, and then using these send and receive ports, send messages back and forth to do whatever you want. They just can't share any state unless, again, unless you set it up through messages. All right, point. So this is just a simple point class just to illustrate some of the interesting syntax here. So we've got a class point. It has two fields, or inst vars x and y. They are of type num, but I could have just as easily typed them as var if I wanted to. This is actually interesting syntax. This is a shorthand syntax for a constructor. So normally in Java, you'd have point, x and y, and then on the next inside the curly braces, you'd say, x equals the incoming x variable, y equals incoming y variable. So this is a sort of a syntactic sugar that says if you have a this dot x, this dot y in the definition of the constructor, it basically it sets up the assignments for you. So you can set up a simple constructor very, very easily. You can also have named constructors. So these are all things you proceed with new. So new point with two numbers gives you a point. New point dot 0. This is the body of that constructor. It sets up x equals 0, y equals 0. Here's another constructor, polar, that takes theta and radius and sets up the x and y. So all the constructors basically set up their fields in different ways. You can also have factory-based constructors, which I'll show you another example in a bit, that they basically let you have a construct that looks exactly like a constructor but can do anything it wants. So one of the things that they were trying to achieve with Dart was consistency across different types of constructors, and you'll see some really interesting things. We talk about accessors like getters and setters, and how they basically look just like fields. So here's the syntax for actually executing these. New point dot 0 for a named constructor. And I've got a method here that calculates the distance if I run this. Yeah, pretty simple. Next, I have an example rectangle. And rectangle illustrates the use of accessors. So normally, as you know, in Smalltalk, all instant variables or fields are private, so you have to create accessors if you want to set them. Same thing in Java. You can create your standard getters and setters, or you can make your fields private. Now, one of the goals with make your fields public. One of the goals with Dart was to make field access and accessors look exactly the same. So here we have a rectangle that has left, top, width, and height, but then we create an accessor for a set of accessors for right. So we say get right, set right, and then use the one-line syntax for defining what it does. And then we look down in this program, then you can basically access things like access or set right and bottom just like they were fields. And it does the right thing. So it's a really interesting syntactic sugar to, basically what it allows you to do is you could start out by creating things as fields, and then later on decide to turn them into computed values with accessors, and you don't have to change any of the callers. So if you got this code here, and notice we have, again, fields left, top, width, height, and then right and bottom are computed. In the second example, we can rewrite width now. We'll have left and top as public variables. Any variable or any field with a underscore in front of it is private. So one of the things that Dart does is establishes the concept that especially there's public variables, private variables. Private variables all have underscore in front of them, so it makes it easy to tell what they are. So width and height now you can't see outside a rectangle, but if we go ahead and create a getter setter for it, where width just returns that internal variable, but now the setter actually does a test, so you can't have a rectangle that's less than 0. But then, the actual application looked exactly the same. So we replaced what looked like a field with a computed or with an accessor without having to changing the code. So that's actually a really nice and results in some very nice consistency in writing the program. You don't have to look at when you're looking at the code in Dart. You can't tell whether the client side, you can't tell whether that field is actually a field or an accessor. So it's pretty interesting. Any questions about that? And then that's the last one. So I've got this example symbol. So here's and this will show a couple things. First, we have a class string wrapper that's just going to wrap a simple string. It has a constructor that just sets that field, and Dart has operator overloading. Similar to how you can create binary functions in Smalltalk, you can basically override any operator in Dart using this syntax: operator, then whatever operator you want. So rather than creating like an equals method in Java, you can simply override the double equal, which is the equality method in Dart. So you can have much nicer syntax in Dart. Object 1 equal object 2, rather than like in Java, object 1 dot equals object 2. Yeah. What?
So why do you have the notion of operator? Is it like to solve this priority problem that you might have, let's say with 2 plus 3 times 4? Or
Yeah, in fact, the set of operators the set of operators in Dart is sort of prescribed. So you can override any of the operators that's defined, but you can't actually create new ones. So, and the standard operators have this sort of standard mathematical precedence. So if you were to do in your standard math example, 2 plus 3 times 4, you get a different answer in Smalltalk and Java and Dart. So Dart will give you the same answer as Java. So The numeric operators all have the standard mathematical precedence. There's a list of operators you can override, but you can't create new ones.